Hi everybody, this is Hans Zhang, and this video is for presentation of my wireless communication project. My project is performance evaluation of turbo code on different channels, and I will divide my presentation into four parts. First, basic wireless communication system. I will introduce you the big idea of the communication system. And then the second part is the implementation of the wireless communication system into MATLAB. And the third part is the evaluation of the results from MATLAB. And the third part is the conclusion. Okay, first let's look at the first part, basic wireless communication system. As you can see in the picture, this is a basic system structure of wireless communication system. And for transmitter part, you basically generated the source data and use turbo encoder to encode it. And then you modulated the signal. And then you send the signal to the channels. You have different kinds of channels and the various channel conditions. And for receiver part is offset to the transmitter. Basically, you just demodulated it first, and then you decoded the signal. Finally, you got output. And I will use the output data and compare it with the source data to calculate the bit error rate. And then let's look at some details of this wireless communication structure. First, I will introduce you the turbo encoder. As you can see in the picture, input information directly accessed to the RC1 and generate parity bit C1. For RC2, the input data first go through the interleaver and then access to the RC2. Finally, generate parity bit C2. Normally, the two RC are the same. The point is to better prevent turbo codes from burst errors that often appears in mobile communication system. And there's another important part which is called interleaver. The interleaver it breaks the patterns in bad input sequence which produce a low weight parity sequence, and therefore improve the performance in turbo coding. And then let's look at the turbo decoder. The most important feature of turbo decoder is that it introduces the idea of iteration. As illustrated in picture, the decoder structure consists of two component decoders, serially concatenated with an interleaver. The decoder corresponds to the RCs in encoder structure, and both encoder and decoder use the same interleavers. Basically, one decoder used output data from previous decoder, and therefore considerable performance gain can be achieved with increases of the number of iterations in decoder. And that's how turbo encoder and decoder works. And then let's look at the channel. In this project, addictive white Gaussian channel will use as the basic channel, which is easy to realize in MATLAB. And I will add some Raytion and relay noise to it, and therefore I can test the bit error rate performance over various channel conditions. For Raytion and relay channel, the main reason we have Raytion and relay fading is because multipass effect. And there are three main mechanisms, which are reflection, diffraction, and scattering, which cause this fadings. And the way to differentiate Raytion and relay fading is whether there is line of sight. But I will not discuss too much about the mass mode of this two, because in project I will use wireless communication toolbox in MATLAB to generate these two kinds of noise, and the details is embedded in the toolbox. And I will add some phase compensations to make the output more realistic. And then let's come to the next part, which is second part, implementation in MATLAB. The program algorithm is basically based on the wireless communication structure a few slides ago. And basically, in step one, I generate the random binary input data, and then I generate random interleaver indices according to the data lengths. And the third step is encoded data with turbo encoder, and then modulated encoded data. and then pass the modulated signal to ration channel and add phase compensation. And you can also pass the signal to relay channel. And finally, you pass the signal to addictive white Gaussian channel. And for receiver, you do the same thing. You demodulate first, and then you decode it secondly. And finally, you get the output, and you calculate the bit error rate performance by compare the output data with the randomly generated input data. And that's how the program algorithm, main algorithm works. And then let's look at into some details of my approach. I will use MATLAB Communication System Toolbox. The system toolbox provides constellation and eye diagrams, bit error rate, and other analysis tools and scopes for validating your designs. These tools enable you to analyze the signals, visualize channel characteristics, and obtain performance metrics such as error vector magnitude. And here I will give you a small example of how the component of turbo encoder works. Basically, I will first create an object, and then I will set some parameters. And finally, I will embed it in the main algorithm. Basically, it's just insert the component into the main loop. So here, let's come to the program. You can see in the red word, comm.turbo encoder and comm.turbo decoder. This is basically create object, and then I will just initialize it by set some parameters here. Then I get two objects, which is ENC and DEC, which basically they are encoder and decoder object. And the following part is basically some other components of this wireless communication system. And then let's go into the for loop here, for loop. And as you can see in the slides, I will call these two objects in the main loop to make my program works well, and I can get output and calculate bit error rate. And this is basically how one component works, and the other components is the same. You just need to put them in the right sequence in the main loop. Then the program will work. Finally, let's move on to the third part of this presentation, the evaluation. I get four picture result from my program. The first is bit error rate performance for turbo code over addictive white Gaussian fading channel. And the second is compare bit error performance between relay and the ration channel. As you can see in the picture, the bit error rate performance was similar. And for the third picture is bit error rate performance in relay channel with or without Doppler. And as you can see in the picture, the relay fading with Doppler shift makes the bit error rate performance worse, actually. And the fourth picture is a bit error rate performance in ration channel with different case. And we can conclude from this picture that the bit error rate performance decreases slowly as the K factor increases. And but the degradation is not very dramatic. And this is all the result I get from the MATLAB program. And finally, let's come to the conclusion part. In this project, I learned how to use MATLAB Communication System Toolbox to simulate normal wireless communication problems. At the beginning of this project, I only know how to test the bit error rate performance for addictive white Gaussian noise channel under QPSK modulation. And then I do a lot of research and successfully add ration and relay noise on addictive white Gaussian channel and using different kind of modulation schemes. And I also find out that after add the noise, we also need to do phase compensation in order to get the better performance result. And now I can test bit error rate performance over various channel conditions. But I realized that for my project, there are still a lot of things which need more research, such as different decoding algorithm and different number of iterations and the different modulation schemes. These things can have an effect on the bit error rate performance. In conclusion, this project can provide a big idea about bit error rate performance over some classic channels and different channel conditions. And thank you for watching, and this is all my presentation.